and then the book circulates.
He
So
bullies Ben,
everyone's
and
getting.
Ben bullies the rest of them.
Does he? But Ben's so like scrawny and stuff.
I literally said
It
I
doesn't
already
mean
said
you
get
can't
out.
bully.
I don't know what I did.
Well, are you guys like pushovers?
I said. That's like basic human like.
Yeah.
All right.
If you're talking about learning how to like speak English, if that's what you get called out, well, that's terrible.
I'm basically the same person outside of the class with maybe more colorful words. Is that roughly right? Oh man. All right, what class is this? I've been in grant meetings all morning, so I get my head's all scrambled.
Just
Well, that is actually the problem is the math. Well, and maybe the math teachers are better here, but like the high school math teachers don't teach math right. I think I maybe even showed you guys like first week of class or something. I drew like kind of what is integrals, like calculus. You learn about integration. I think I asked the question like, what is integration actually solving?
like in the beginning.
Huh? Yeah, it's the area of the curve, but you're basically just approximating a whole bunch of rectangles, the area of a rectangle, length times width, and then the area of a triangle, 1/2 length times width. Add them all together next to each other, you got the area of the curve. That's integration. A whole bunch of triangle and rectangle areas. All right. So let me just run this and see where we left off. I remember we got from one room to another. Okay, so we have the thing, I think we can do a look, and that shows us the room we're currently in. We could do an exit that will get us out of the room. Otherwise, we can type in something else. And we see here that we obvious exits here are room to R2. So we can type in R2 in any case, and that'll take us to R2. We maybe should have it show us the room when we first arrive there, but whatever, we could just type look again. Now we see what do you want to do? See, we're in room 2. Also here is Mike, but we don't have a way out. We're trapped in this room. We decided it's a prison. All right, go ahead. I don't know if I did I? All right, hold on. I'm sorry. Always feel free to either message me on Slack or text me or email me if I didn't do something that I said I was going to do. I'm currently working on 4 different government grants, so I'm running ragged. So, well, I was working on 3. I just got into a 4th an hour ago. All right. So as of now, we only have a next room type thing. What we might want to do is we might want to start thinking about having the ability to have exits in multiple directions, north, south, east, west, something like that. And in that case, we need to start thinking about how do we actually handle exits? Because right now, every room just kind of has a pointer to the next room, right? If there is one. Oh, and by the way, what we just wrote here is what's called a linked list. We've hidden it inside of the idea of rooms connected to other rooms, but a linked list is a data structure, a linear linked data structure that you learn about in coding 3. We just wrote it. Not that hard, right? Our payload is a name and what else is in our room? A player. So each of our nodes, we have a name, a player, we have then a next room. Usually when you learn linked lists, it's called a next node, and you go to the next place. So this is coding 3 stuff. Yeah, last room points to null or point to another pointer called tail. So then you get doubly linked lists where you can go back and forth. So if we added, for example, inside of a dungeon, if we not only told R1 about R2, we also told R2 about R1. We're hard coding all this stuff, but we also did that, then we run it. Now we can just go back and forth between the rooms. So we can go to I got to click down here, I guess. I can go to R2. I'm there. If I do a look, we can go back to R1. I'm there. We do a look. We can go back to R2. We're there. We do a look. Let's go ahead and have it look for us real quick. So what we're going to do is for room, when we add a player to a room, we're going to go ahead and say so-and-so has walked into the room, and then let's go ahead and ask this room to display itself. So a room has a display function, this dot display. So it already is going to show itself, but let's just make that automatically occur so we don't have to type look when we walk into another room. So we just added this dot display at the end of add player. So now we go to R2, shows us that we're in the next room. We go back to R1, shows us we're back in that room. Go back to R2, yada, yada, yada. Very exciting dungeon.
So it just tells you exactly what is in the room.
Yeah, but that's what we wrote. Yeah, I mean, this is our display function. That's what that guy has always done.
Yeah.
It gives us name. If there is somebody else there, it tells us that. If there is another room, it tells us that. So all we're doing is whenever a player is added to a room, after we've done all the magic and we say so-and-so has walked into the room, we then go ahead and just tell the room to display itself so the player sees it on the screen. So at this point, this is a single player game. So the game is only communicating with us. All right. We'll see if we get to a multiplayer thing, but we're definitely going to do a multi-threaded thing. And we'll definitely do a thing where we can kind of customize our maps. But for now, we want to think about an exit. The idea of a room. Let me open up. All right, the idea of an exit. So as we have it right now, we have two rooms and we just have a room has a next room or it doesn't. So a single pointer to the next place. If we want to think about this in terms of the cardinal directions, we might have a room to the northeast, southwest. We want to think about how do we handle that. And then do we want to start creating something that lives as like a wedge between rooms? Is there value for that? Kind of like taking a portal. So a door might be a portal to another room. Does that make some sense? Instead of just a pointer to it. Let's do it the most obvious way first, and then let's kind of consider the pros and cons of that. So right now we just have a single pointer to the next room, and then we get there by the name of the room, right? So if I want to have an exit to the north, the south, the east, and the west, what might be the simplest solution to that? Go ahead. Okay, so that's not the simplest, but it's probably where we're going. Go ahead.
Do a dictionary with the
Also not the simplest. We right now can go to one room. If I want to be able to go to four variables. Yeah, well, let's just go with that, right? Take one little step and then look at how we can make it a little bit better. So for right now, we're going to go ahead and update room, where instead of having a next room, I'm going to call this north, south, east, and west. And yes, you can define multiple variables of the same type on one line. So there's an opportunity to see that. If you don't like that, just put it on 4 different lines. Nobody's going to yell at you. All right. So now if I run the program right now, things are going to break, right? Because I just ripped away the idea of this next room thing. So now we need to go and update the things that are broken to fix this, but we're going to bump into a problem. In fact, actually, just for right now, since we're going to be testing, let me just go ahead and leave the next room in there. Just so it's not broken at this point. We just have some new variables. We'll go ahead and add the new feature and then we'll delete the old feature. All right. All right. So let's go back to Dungeon. And now let's create a couple more rooms. So let's do R3, R4, R5, R6. Yeah, let's do that. Actually, hey, let's throw a Christian worldview into this puppy. Let's go down here and we're going to build a map. The map is going to look like a cross. Whoa, whoa. Yeah. So now when you do your evaluation, I get the Christian worldview checkbox. An interesting thing is I actually have a certificate in apologetics. This personality is actually a kind of a Christian teacher type thing. Yeah, I don't understand it either.
I don't believe.
It's true. And my wife is like a super Christian. So God has a good sense of humor. Trust me. All right, so I guess I made this a little bit weird. Let's just, let's rename number them just so we have some sanity here. Let's go R4, R5, R6. All right, so we're gonna build this dungeon. And again, for right now, we're gonna hard code everything. We're eventually going to say we can design our dungeon. We might even write a program that is a dungeon designer, where we start off in an empty room and then we could say, add room to the north. So poof, puts a room there, and then we can head to the north and say, add room to the west. We can poof, go there, go back to the east, add room to the north, whatever, so we can kind of stand in that room. That's actually really cool to do in VR, where you can, you just point at the place on the wall where you want to put a door and zap it, and now you have a new entrance, and you can kind of drive around your dungeon. And then at the end, you export it to JSON, and then you could take it to our text-based thing, and that's your map and your text-based thing. Map builders in VR, the actual dungeons in text. All right. So let's go ahead and build this guy. We'll build our 6 rooms first. So one, two, oop, gotta count. I'm still learning my numbers. All right, we got our 6 rooms, our 2, our 3. Our 5, our 6. All right, so now we got to go and kind of build out this this dealio. So we have R1 leads to R2, R2 leads back to R1, right? And then R2 also leads to R3. So let's bump into our first problem and then look how to solve it. So R1 goes to R2, R2 goes back to R1. So we've built this relationship right here. Now we need to do R2 goes to R3. So we'll say R2 dot add next room R3. Okay, so now we have a problem. What's the problem? We just destroyed our exit back to R1 from R2 because now we say R2 goes to R3. When we look at our map, we really want this thing to go to the south and this thing to go to the north. So just adding a next room is no longer good enough. We need to say, I want to add a room to the north. I want to add a room to the south, whatever, that type of thing. We had to give it some direction, right? All right, so let's go ahead and build that in. We're going to still leave our current stuff in place, but we're going to have it broken here pretty quick. All right, so let's go into our room because that's really what we need to do. Right now, our room is not as capable as it needs to be, right? Our room can only take in one next room, and we need more than that. All right, so let's go ahead. And we're not going to get rid of add next room yet. We will delete it, but let's just we'll build the addition first, and then we'll knock down the old stuff. So we're going to say void add, let's call this add exit for right now. All right, and this guy is going to take in a room We'll call that guy the room. And then a string direction.
Have we, created all the room and
This is just the name of the variable. I could have called this woot. Remember, this is a function. It's expecting me to pass in a room, and whatever I name it here is how I have to refer to it inside this function. So you get to pick what you call it. I like referencing them as like the room, the player, kind of almost like a micro sentence that it spells it out. All right. So, but you do you. If you want to name your variables, I think at some point I probably mentioned that Swift lets you use emojis for variables. I think it's disgusting. That is ridiculous.
Sad face.
Seriously, it's ridiculous. But leave it to Apple. I'm a Mac user, but I run all the other OSs. But man, that's a bad programming language. Well, it's a good programming language. Actually, no, it's a bad programming language. I don't like that language. I think I mentioned it doesn't handle strings nearly as nicely as it really needs to. Whatever. That's a whole different. That's a rage thing at the lunch table. All right, so we're going to add an exit. We're going to add this room to a specific direction. Now, we've decided in our game that we're only going to allow 4 potential directions. All right, and we just happen to have rooms for the north, the south, the east, and the west. All right, so we need to ask some questions. We want to say, well, if you are adding this to the north, we're going to go ahead and set our north variable. If you're adding this to the east, we're going to set our east variable, so on and so forth. Oh, you're awake. Oh, okay, so let's ask our question. So if direction dot equals, and we'll go ahead and say equals ignore case, because whoever's using this, if they type in east with a capital E or whatever, it's not the end of the world. We know what they mean. But we'll say equals ignore case. So if they typed in north in any case, then we're going to go ahead and say this dot north is equal to the room. We'll set that guy. Else, if the direction dot equals ignore case is south, this dot south is equal to the room. Else if, rather than copying and pasting, I would encourage you to type the stuff until you start finding that that's just annoying and you know how it works, then you could copy and paste stuff. All right, so direction, it's good for reps. Figure out where you typically make your mistakes. I typically misspell things because I have fat fingers and tremors in my left arm, but it makes it fun. All right, so equals ignore case. Let's go with west. If that's what they put in, we'll say this dot west is equal to the room. Oop. Oh, Ninja. I'm seeing extra poorly today. This is all just a blur. All right, so else if, and notice a little change here in Python, it was elif, E-L-I-F. Now it's else followed by if. And actually, it is 2 separate things. This is actually an else opening curly brace, if opening curly brace. So remember when we first talked about conditionals? Well, at least in here, I talked about always put the opening and closing curly braces, even though you technically, the syntax tree for an if statement says, if this statement, all you need to have under there is the statement. So if you're only going to say one thing, you actually don't need the curly braces. But it's never wrong to put the curly braces. Yet technically what is going on here, by that rule, I should be writing it like this. That means the same thing. Does that make some sense? So really, I'm breaking my rule a little bit by saying, okay, look, let's put some limits on our insanity and be able to say, okay, look, this is good enough. An if statement is a single statement. Therefore, we will allow ourselves not to use the curly braces. We'll also allow ourselves, this is to you, Logan, we're going to allow ourselves to have the statement on the same line as the thing instead of kicking it down a line. All right, good. And then you.
Yes.
No, you first and then.
So like what we're saying, like this dot north.
Now we got another sleeper. I'm so loud. How do you sleep? You can sleep if you want. I don't care. It's not going to offend me.
I'll try to not.
Doesn't matter. We're recording it. Hey, I get it. Sometimes you just need a nap. All right, go ahead. Sorry.
No, you're good. I was just gonna say, like, when we're saying this dot north and this dot south, and we're setting that equal to the room.
Yep.
What does that do to the room?
Okay, well, so here's the variable that was passed in. So this is the room. Somebody somewhere else called add exit. They passed us a room. We are now locally calling that the room. That's the name of that variable. So what we're doing then is we're taking whatever room was passed in and we're setting our field called north. This guy right here. So this room currently has 5 variables, but let's just pretend it only has 4. In fact, let's just do it. So right now a room only knows how to go north, south, east, or west. So we currently have 4 different variables that can hold an incoming room. So down here, when we're adding an exit, we are, let me dump this too. So when we're adding an exit, we're passing in the room we're adding. This is going to be where that exit goes, as well as the direction we're adding it. And then we're just asking some questions. Well, if you want to add it to the north, we will set this particular room's north variable equal to the room that was passed in. Some other place might have passed in something called R1. So R1 comes into this function, but now locally we call it the room. That's just the nickname we've given it for this inside this function. Does that make sense? So we're just situationally, depending on the direction they told us, we are setting the correct field inside of this particular room so that these guys are webbed together in the right way.
So if we decided to go into the dungeon and we're trying to do what we're doing now, which is like set a room in a certain direction.
Let's do it.
How would we call that?
Well, so let's do it. Let's call this function from our dungeon. So our dungeon is where we're creating all our rooms. So now, what did I call this guy? I know it's not complete yet, but it's good enough. So we're calling this guy add exit. All right, so a room has a new function called add exit that expects me to send it 2 things right here. The first thing it wants me to send it is a room. Don't worry about what the room is called here. It needs a room named whatever, but a room from somewhere else. It also needs me to send it a string. The implication is that string will either be north, south, east, or west. But if they send me something different, we're going to have an else statement at the end that's going to say, I don't have that direction. There's no wall in that direction. Some of these games have also like an up and down or a climb sometimes, this kind of stuff. But anyway, so here in Dungeon, we've created a bunch of rooms. We are trying to mimic this map. So we want to go from R1, we want to add an exit to the north. We want to put R2 to the north of R1. So we'll say R1 dot add exit R2, and then we'll pass in north. So that's an example of calling this function. So we've told R1, I want you to add an exit. R1 says, okay, I'm going to need a room and a string to do that. We hand it R2, here's your room, and we hand it north, here's your direction. Here's your string. Here in room, we catch those 2 things. So inside here, R2 is actually called the room. And that north string we've stored inside of a variable locally called direction. All right. So then we ask our question, and we're going to get into the very first if statement. If the direction they passed in, which we saw was north. So if the direction they passed in is equal to north, then we'll go ahead and set this particular room, and this particular room in this case is R1. This, the variable this, the keyword this right now equals the same memory address as R1 equals inside of our dungeon. All right, but we don't have access to R1 inside of here. So instead, this is why we need a variable like this. So we have a way of talking about ourselves because we don't have that variable from somewhere else, whoever called this in scope. So we'll go ahead and say this dot north is going to equal the room that we want to go to. Does that make some sense?
Yeah,
Sure, go ahead.
so like, the reason why that was put in R2 is because we called R2 originally, or we made it in, like, right there. It was of the room class.
Yep. Yeah, so I've created 6 instances of room. So you can think about, I have 6 Legos sitting here, they're all rooms. And what I'm going to do is I'm going to take this first Lego, I'm going to take the second Lego, and I'm going to say, I'm adding something to the north. Boom, throw it in there, and now he's created this link.
And that's how we connect the different classes, is just being able to like create,
Connect to different, well, so this, I mean, we're building this. So this isn't like something that's like, okay, you know, so Java is like us going to Home Depot and being able to get a whole bunch of materials, right? And then here we invented some materials. We invented the idea of a room, and we describe what that is. We invented the idea of a player, the idea of a dungeon. And now we're using these ideas to bring instances of those into existence, and then we're writing functions so that they can work together in the ways that we're also inventing. Okay, so we're using Java as kind of our language to describe the world. This is AI prompting before there was AI prompting, right? We're the AI in here. We're following our own directions and building out our network. All right, you had a question.
Yeah, potentially it can, but back in the room, so when was this?
Tangent is derivative of function.
Back last week when we were trying to do the switching between rooms for homework, I added dot contains so that if the input like contained the word exit, so if I typed in I want to exit, then it would exit.
Okay. Yeah, so what he used a different function, right? So instead of using dot equals, you use the dot contains. So let's go look up the thing in the documentation. Dot contains is actually just going to search for whatever they passed in. If some aspect of it, somewhere in that string, it had the thing. So if I do Java string class, here's our string. A, B, C, D. Oh. Contains right here. So here's contains. It takes in something called a char sequence. We can go and follow the yellow brick road and click that, but let's just say it's a string. It'll behave as a string. In fact, I bet you it even doesn't inherit from string. No, it actually is an interface, which we'll talk about, but I'm not talking about it right now. And we see that strings abide by the rules of that interface. Okay, think of it as like it's USB compatible, except in this case, it's char sequence compatible. All right, so every single device that's USB has to follow the interface instructions. All USBs have to have this minimal set of things to make it work with any USB port. So in this case, it's, hey, you got to give me something that at the very least plays by the rules of char sequence. And char sequence says it must have a char at, it must have the ability to get chars, code points. It has to have a length, a subsequence, and a toString. And so anything that's going to follow this has to implement their own versions of those functions. Otherwise, it's not going to be compatible. All right. Go back here. So if we look at contains, we see returns true if and only if you're doing a math class, that's IFF. If and only if, probably physics too, I think. So if and only if this string contains the specified sequence of the char values somewhere in the string, anywhere in the string. So you could have LOL north woot. I know I'm using those terms a lot, but I have a very small young people vocabulary, but I think that's still an old people vocabulary, whatever. So it would return true for that if you said, does it contain north? So you'll maybe get some false positives, but that's a powerful tool if you have like a sentence and you want to know if that sentence contains the word and or something like that, or if you're looking for vowels, maybe. Okay.
Can you do both equally north-east and?
Well, yeah, if you want to. I mean, you could say, does it equal north and does it contain an O?
Right. But how would you do that?
Oh, okay. Well, so, oh yeah, my thing is in here. So let's go. Yeah. So you might say, if it equals a lowercase north and direction dot contains, I don't know what an OR, then it would be true, something like that.
Great.
Yeah, you'd have to come up with like a situation where that would be helpful, but they certainly exist. So there, I mean, that's actually a really good example you gave is that, let's see, where are these things? Is that, you know, you're not going to memorize the entire programming language. I happen to have known that what contains was, but you know, so this is kind of like you going shopping. You know, you just bought this tool, right? You just bought something from Home Depot, and how many of you read the instructions cover to cover? None of you? My wife always does. Always. That's what I'm saying. And then I electrocuted myself 3 times. Also a true story. So in any case, we're not going to have all this stuff memorized. So if I know I have a string, I can go here and see what is that dude capable of. Just like if we're connecting this back to stuff we're inventing here in our code, if I have a room, I can go into the room class here and see all the things that guy's capable of. Make some sense? Because I'm writing a bunch of stuff, but we might have written something 6 weeks ago and we don't remember that feature. We got to go and look like, okay, what's the name of this function? Does it even have the ability to do that? Or do I need to build an addition? You know, who knows? Go ahead.
Does that function like work in general sense? Like, are you just checking different stuff?
Oh, like how would you write contains?
Yeah, like and inside of a, say you had a sentence or something.
Yeah. So you start at the beginning of it, you're looking for a specific sequence of characters. So you look at, so now you know you're looking for the word and, let's say. You know it starts with an A. So you're going to go through until you finally hit an A. And when you hit an A, then you're going to say, okay, well, is the next guy an N? If it's not, you'll keep going and say, well, is this an A? Is this an A? Well, you finally get an A. Well, is the next letter an N? Yes, it is. Okay, well, is the next letter a D? So you'll probably have a loop inside of a loop to kind of have that starting point. Here's the index is 3, where I found an A, and then start from 3 and see if it matches up to the rest of your guy. Yeah, not a real hard thing to write. I'll put it on the final. It's not a hard function.
Oh.
I probably won't put it on the final, but it's. But what I want to, I mean, this is another good question. Is those kinds of things, like these things sound like magic, but they're not hard to write under the hood. These are simple things, but they're just conveniences for us. So you don't have to write the stupid nested for loop that's just searching for substrings. You know what I mean?
Yeah.
You know, we can say that a cousin of this guy would be the string substring function. So somewhere in here, oh, I'm in the right place. I always have to say my ABCs to find it. All right, so somewhere down. Okay, so here's some other helpful ones. Just I'll introduce a couple of methods and for strings that you might want to just kind of tuck away in the back of your head, knowing it exists. So for instance, we have one called split. So let's say you have a string that has several different pieces of information delimited by commas. You can say split on a comma, and it'll give you an array of strings with each individual piece. Very convenient. Sure, you could write the code to do that, but it's already built in. Yeah, every language has it. Yeah, I mean, these are power tools built into it. When you go to Home Depot and you buy a string, every single string, regardless of brand, you expect to be able to do split. You expect it to be able to compare itself to other strings. There's some kind of, common sense things you expect it to do. Substring is another one. Substring says, hey, notice there's a couple versions of substring here. What is it called when you have more than one method with the same name that takes a different number and or type of parameters? You don't know it? Were you even paying attention? What is it called when we have two functions with the same name, but they have a different number and or type of parameter?
I don't remember what it's called, but I know what it is.
Yeah, you said it before, bro. You told me it, and now I forget it, and you forget it.
Starts with a P. O. L.
Yes.
Polymorphism. All right, so I gave you half the word. You're probably terrible at that game, Wordle.
I only give you like a Pokemon. Oh, now John's playing more.
All right, so this will happen often because look, and here's an example of where polymorphism can be handy. When we think about a tool like substring, this first one says, okay, if you have a string and you want everything maybe after the third character, you could take a substring from there all the way to the end. So in that case, you'd only give it the begin index because I want the rest of it starting here. Alternatively, you could say, look, I want some part of that string. Maybe I want everything from bucket 3 to bucket 6. Give me all that. I don't think 6 is included. I think it's exclusive, but mess with it, figure out if it gives you the right final letter, if it doesn't, add 1 to your end index, something like that. All right, so you can turn a string into a character array. If you happen to need it in an array of chars, you can get that. You can convert a string to lowercase. You can get a toString from a string, which is actually related to the object thing that takes in a string. It just calls the strings toString. Go ahead.
So final would be in Python or Java.
It probably won't matter. I'll probably give you Java code for examples, but
Well, it's good to know for us.
anything you need related to that, I'll give you. Yeah, I mean, the exam is certainly going to lean into that idea that coding is the skill set, the language doesn't matter. So maybe I'll even make the exam in C#. I mean, well, okay, so we'll make the exam in how about Scheme? Nobody here knows Scheme, right?
HTML.
HTML is not even a programming language.
Simply. Dude,
All programming, I said that we're reviewing. He said HTML. Why isn't HTML a programming language?
no, they can't change it.
Okay. All programming languages have the ability to do what?
Store.
Remember things, ask questions, repetition. HTML can't do any of those things. JavaScript always comes along for the ride with HTML. HTML is our way of describing our interface. Still super important, right? It's a data representation language. But JavaScript is riding shotgun because he's the guy who can ask questions and remember things and do repetition and all that stuff. All right, so Rust. The Rust is fine.
Let's do the exam in assembly. That's what I said.
Please.
Yeah.
Well, you haven't had that class yet, so that wouldn't be fair.
Maybe let's choose Grace, you know?
I'm liking Scheme. How many of you have ever seen the language Scheme? It's one of my favorite languages.
Oh, let's do the exam in Scratch. You know, do the whole.
Oh, yeah, they're gonna.
Or Google Blockly. So most languages have a way of taking a string, converting it to lowercase, converting it to uppercase, blah, blah, blah. They can, Those aren't great examples. All right, so let's just leave it at that for now. But bottom line is, this is your user manual for strings. It tells you all the stuff it can do. Realistically, you're only going to use 3 or 4 or 5 of these things ever, right? But you can go in there and see some weird thing that it might be able to do, just like when you buy a gadget at home, right? You're buying it for 3 functions it can do, but it might be able to do another 8 things that you're never going to use it for. So you just don't push those buttons or put it on that setting or whatever it is. All right. So the push there is understand that this is the way we already solve problems in real life. You know, you got to get the intimidation factor out of programming because it's the same thing. All right. So we're in rooms. We're in the middle of adding an exit. So adding an exit takes in a room, it takes in a direction. If they gave us north, we'll set the north variable. If they gave us south, we'll set the south variable. If they gave us west, we'll set the west variable. If they give us east, we'll set the east variable. Oop, Ninja. You couldn't just help me out with the final curly brace? This dot east is equal to direction. Nope, sorry. Is equal to the room. All right. Now, if you didn't give me any of those, if you didn't give me a north, south, east, or west, I'm going to go ahead and just have a catch-all else. And maybe do like a system dot, I'll go ahead and do something here that we haven't done before just to show it to you. System.err.println.
Or is it like you receive an error?
That is not a valid direction. Well, let's go look at the manual. All right. We're going to find that there is a print stream inside of system. So let's do this. Java system class. All right. We're going to look at the fields. Notice we have 3 fields. One is called in. That's the one we usually use. System.in is a print stream that writes out to the monitor. System.err is a print stream that writes out to the monitor. Why do I need 2 different print streams to write out to the monitor? Okay, well, why do I need 2? Why can't I just write errors over the same thing if it's all just going to the screen?
Can't like.
This is an operating system concept that we're talking about.
One for all.
Why? It's printing to the screen.
But you're handling errors with one. And
So?
then you're like putting it to the other.
It's all going to the screen.
But recognize the difference between putting an error.
Say this again.
You don't want to.
Yeah, I won't be able to tell the difference between an order.
Okay, so maybe you have a program that cares which of those 2 print streams that is coming out, and you choose to show only the errors of it or something like that. Could be. Also log files. Most operating systems, you know, they'll have these log files that contain your errors and stuff like that. So there is a way to say direct all things that are over the error stream to this log file. Don't give me the output of every single program. So it gives you the option to situationally collect only the errors. Otherwise, if you're not doing anything extra with them, they all go to the same place. Just comes out to the screen, but it gives you that option to do those. Notice we only have 1 input stream. That's the keyboard. We can create other input streams. It just doesn't come with system. So you can go to the input stream class and you can make an input stream that comes from like a network socket. If you're writing network aware things, we'll probably write sockets, if not this semester, next semester. All these things sound intimidating, but they're easy. I mean, it's reading in from a socket is the same thing as reading in from the keyboard. We can build a scanner, and instead of passing it system.in for the input stream, we just give it the get input stream from the socket. Now it reads from the socket. Sockets are connections between 2 computers, 2 IP addresses. All right. All right, what am I doing? All right, so I'm just going to purposely put in the system.err thing, even though we're not doing anything special to it. It's just going to spit it out to the screen. But we're going to yell at them and say, hey, look, I didn't do anything here. What you gave me is not a valid direction.
Is that also what we want to do? Because if we don't, then it'll just give us an error, like the regular errors we get and stop the program altogether.
Well, in this case, we're not stopping the program.
Yeah.
In this case, we're just saying, look, this did not work the way you maybe thought it was going to work. So you're kind of just giving like the little buzz, try again. All right. And I updated it a little bit. I'm put in here the direction you gave me specifically. I'm going to insert, and it's actually not this dot direction. It's just direction. The direction you gave me here, we're going to actually put it here, is not a valid direction. So if we put in like, I'll just keep going with it. We put in woot. It's not going to like that. It's going to spit out woot is not a valid direction. All right. So let's go finish building our dungeon here. So we're saying R1, add an exit to R2 to the north. Let me just get rid of these two lines. Then when we want R2, add an exit to the south to R1. R2, add exit leading to R1 in the direction south. R2, add an exit to R3 to the north. Now we start feeling how tedious this sort of is for even a small map. So it might be nice if we have a way of kind of automating this from like an external file or something. We'll get there. But right now we're going to live with the tedium. All right. So we have R2 to the north to R3. That's what I just did, right? R2. Oh, nope. R2 to the north to R3. Then we have R3 to the south to R2. R3. Add exit back to R2 in the south. R3, add exit to the west to R4. R3, let's just keep finished with R3. R3, add exit to the east to R5. Then let's just go in order. R4 to the east to R3. Oh, I haven't done that yet. Thank you. So I'll put it back up here. R3, add exit to R6 to the north. See, I did it on purpose. Good catch. We would have found out when we got to R3 and couldn't go to the north in our dungeon. That's where the boss fight is. You're not ready for that yet. That gets unlocked once you're level 10. All right. So R4, we already put the east, right? R4, add exit to the east, back to R3. R5, add exit to the west, back to R3. And then R6, add exit to the south, back to R3. All right. So that looked good. Did we build our cross dungeon? All right. So now we have to go and update our display, because our display is going to, when it shows me the obvious exits, it's not just going to say, is there an next room? Now it's going to say, well, if there's a room to the north, say that. If there's a room to the east, say that. If there's a room to the blah, 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 blah. All right. So we're going to do this by saying, let's go ahead and give ourselves a little function that will build up a string that has all the directions it goes to. All right. But if it's the empty string, there are no obvious exits. Let me just make sure that was just a early morning mistake. Sorry. Oh, supposed to go for a walk. Later. All right. So whatever. I might have accidentally done that instead of my 11:20 alarm. So if I don't stop in time, somebody scream at me. All right. So we're going to go ahead and add a function that's going to build us that exit string. That way we don't have to put a whole bunch of if statements in our display function. So this guy will return a string. We're going to call this build obvious exits string. Now, I'm going to go ahead and start putting some private stuff in here. So I'm going to say this guy is private. Now, when I make a function private, what does that mean? It's only accessible inside this class, right? Because I'm really writing a function that's kind of like a helper function for us in here. I don't really want people outside being able to call this. This is just for us, right? All right, so build obvious exits. Maybe we create a string called answer. That's the empty string, because right now we have no obvious exits, right? All right, then we're going to go ahead and start asking some questions. If this dot north is not equal to null, and I think technically in my constructor here, I didn't actually set these, so let's go fix that real quick. The default value is null, but like I've taught you, it's good to set it to the value you want it to be. So we'll say this dot north is equal to null. This dot south is equal to null. This dot east is equal to null. This dot west is equal to null. All right, so we've just defaulted all of them to null. So down here in our little helper function, build an obvious exit string. If this dot north is something other than null, that means it's a room, right? We've set it to that. Well, let me show it to you now. This is the way I would write it. But something you could, good. You actually can do that, but I also wouldn't write it that way. But let's assume that you have an object. At some point, we will have an example of this that'll make some sense. In fact, we definitely will when we have inhabitants. When we do inheritance, we're gonna have our dungeon is filled with inhabitants, and inhabitants can come in the form of players or in the form of monsters. So we might ask the question, well, is the inhabitant we're looking at, is it a player or is it a monster? We do have a Boolean operator that I will show you again when it's appropriate, but I'll just mention it now. We can say, is this guy an instance of room? And that will return true if this dot north contains an instance of room and false otherwise.
Isn't this dot north already an instance of room?
No, that's actually a good question. So I'm glad I did this. Here is this dot north, right here. I defined it right here. Is that an instance of room? Tell me why you're wrong. That's true. So what is this dot room? It's a container capable of holding an instance of room. So this dot room is a variable. That's all it is. Variables may or may not actually hold a value. The type of value that might live inside of this dot north is an instance of room. But this dot north itself is not necessarily an instance of room. Right now, it would resolve to null. Go ahead.
Isn't the capital R bucket? Or is it the people create?
No, capital, this guy right here? No, so this is the variable type of this variable name. So we're in a strongly typed language, so we have to define the kinds of values that are allowed to live in this variable. So we're saying that north, south, east, and west are specifically containers that are built only to hold rooms. Make sense? All right. So, he's trying so hard to stay awake, it's hilarious. I keep seeing like one eye close. My wife, my wife's a cancer patient, so she gets very tired sometimes. We'll be in the middle of a conversation, she starts nodding off. Yeah, so she's not listening to what I say. That's when I ask for permission for all sorts of stuff. All right. Build obvious exit. So if, and I'm not going to use the instance of thing here, but I just wanted to kind of throw it out there so you could toss it in the back of your head that there is a Boolean operator that exists that lets you ask, is a certain value actually an instance of a certain class? If that was ever handy, and we will have examples of that. All right, so I'm going to say this dot north, if this guy is not equal to null, that must mean we've put a room in there, because that's the only thing that can possibly be in there for us. So then we'll go ahead and say answer is equal to answer concatenated with north. And what I'm going to actually do is I'm going to put a little space in there just so I don't have to worry about whether or not there's spaces between these guys. It'll have a leading space and then there'll always be spaces before the things. So this is more of convenience. All right, now I'm about to trick you, so pay attention. This dot south is not equal to null. Then we'll say answer is equal to answer plus, so plus is concatenated with south. Is this okay? Well, first of all, will this compile? This will compile. This is not bad syntax. I don't think so. Did I make a mistake? No, we're good. But is this actually what we want?
No.
Why?
You're only checking, like, you only concatenate it once, like, you're not checking, you need just ifs.
Yeah.
You only check, do it one thing and it'll exit out.
Yep. So with an if statement, as soon as we get a true, we fall out of the whole structure. So we won't even check any of the other else ifs. We want to build a string that is representative of the result of a whole bunch of individual questions. If there's a north, add north to this guy. If there's a south, add south to this guy. If there's an east, add east to this guy. If there's a west, add west to this guy. Make sense? We don't want to have else's in there because then we'll miss everything that's after our first true. All right, so this is just going to be a completely separate question. So if it's south, do that. If this dot east is not equal to null, well, it's not that the direction you want. It's, let's just, so put the else back in here. Let's assume that north does have a room in it. So its value is not equal to null. In that case, we will add the word north to our answer, but we won't even check this. Else's only happen if we didn't get into previous guys. Yeah, so we might have an exit to the south, but we're never going to add it to our obvious exits string because we had it inside of an else, which is just like, well, if that didn't work, check this. Well, really, we want to check all four things individually. Go ahead.
So the purpose is, like what he was saying, you're identifying where you can go. But why is it being set to one variable if we're trying to figure out?
I'm building up a string. This is just a helper function. This guy's whole job is I say, give me my obvious exits in a string format. So he might give me north and east as a string. Then I'm going to use that inside of my display method to show the right stuff. All right, so if this dot east is not equal to null, then we'll say answer is equal to answer concatenated with east. If this dot west is not equal to null, then we'll say answer is equal to answer concatenated, concatenated with West. All right. And then when all is said and done, after we get through, oh, I got to take my else out. After we get through the series of 4 if statements, answers should have the collection of potential directions you can go from this room, right? So I'm going to go ahead and return that string for whoever called this function to use. All right. So the name of this string is build obvious exits. The name of the function rather is build obvious exits. So where is my display? Here's display. So what I'm going to do here is instead of asking if this dot next room is null, we're going to go ahead and always show the obvious exits, even if there's none. So, well, first of all, next room no longer exists, but I'm just going to say, okay, I'm always going to print out to the screen obvious exits, and obvious exits will be the result of calling this dot build obvious exit string. Make sense? All right. So let's see, have I taken all these specific errors out? I think we can test this at least for R1. We can't go to rooms yet, but when I run this, we should see an exit to the north, right? We don't necessarily know that that room's called R2 yet because we haven't walked in there, but we should know there's an exit to the north. All right, so let's see where I forgot to fix stuff. Room 19. Oh, thank you. So when we leave a room, ooh. Let's just comment that, well, we're in room. This is fine. Okay, this guy needs to go. So leave room says, I'm going to leave this room. So that's where we're saying this dot the player is null. But I need to go to, before there was only one choice, which was the next room. Now there's a choice of north, south, east, or west. So I'm going to go ahead and I'm going to pass in the destination room to this guy. So this guy will be this dot, not even this dot, just destination dot add player, this dot the player. And we'll walk through this when we actually do this, but effectively when we're leaving a room, what are we doing? We're putting the player into wherever they want to go, which we're going to send into this, either that north, south, east, or west room. We could ask the question in here, but actually we couldn't. We don't know what they typed in. But we're going to put in the room that they're going to so that we can just say, whatever room you want to go to, we'll go ahead and add you to that room, and then we'll remove you from this room. All right, where else did I leave a break? 20 or 77. Nope, this is a dungeon. Sorry. So
now that we've added, a parameter to the leave room, if we go into the dungeon class, at the very bottom of where you are, like, we have to put something into that room.
oh yeah, I mean, we're not going to be able to traverse yet.
Okay.
Yeah, it's right now, what we want to see is we want to get kind of, so, because obviously we have the next room throughout our code, so I'm just running it to see the error messages to go track down all the places we still had that. So right now what we expect to see is we're sitting in room R1 and we see an obvious exit to the north. That's what we expect to see right now. All right. So, let's see, this is the loop for stuff. So actually what I'm just going to do for right now, I'm going to take this out and we're going to say system dot out dot println try to leave to the what do I call it, input line? No, that'll be north, south, east, or west, or whatever they typed in. Add code here. For homework. All right, so now we are in our game. So we get the mic walked into the room initially when we first entered the room. So it is a little funky that when we walk in, we get a add room. So it's looking twice, but let's not worry about that right now. All right, so we are in room R1. We see that we are also here. And obvious exits are to the north, right? So look should still work. Get a clip down here. Look should still work. Exit should still work. If I type in north, it's going to say try to leave to the north. If I type in woot, it's going to say try to leave to the woot. Blah, blah, blah. All right. So what we want to do is let's go ahead and add in the ability to find out, is there an exit in that direction? We should be able to ask a room. I mean, we have a string that tells us there's an exit to the north, but we want to be able to ask that room, do you have an exit to whatever the user typed in? It might be north, but it also might be woot. So we're going to build our own Boolean function inside of room so we can ask a room, is there an exit? So this guy will return a Boolean. It's going to say, let's maybe call does exit exist? String direction. All right. So we want to ask the questions if direction is equal to north and this dot north is not equal to null, return true. If direction dot equals ignore case north and this dot north is not equal to null. So if both of those are true, if they asked me if there's an exit to the north and there is an exit to the north, there's something in that variable. If both of those things are true, we will return true. Else if direction dot equals ignore case south and this dot south is not equal to null, return true. Else if, and yes, if you're thinking already, we can make this a single Boolean expression with a bunch of ors next to it, but this is cleaner. This makes more sense instead of having the monster Boolean expression. Let's just ask several questions. Remember, computers are super fast. We're not going to notice. So else if direction dot equals ignore case west and this dot west is not equal to null, return true. Else if direction dot equals ignore case east and this dot east is not equal to null. Did I? Thank you. I did it on purpose. Return true, because I don't make syntax errors. So else return false. All right, so we're gonna say, is there an exit in this direction? And it's going to give us a true or a false. So this is called does exit exist? So out here in Dungeon, we're going to conditionally say, try to say, so we're going to say if. Now we need the room that we are currently in. So that is the player dot current room, that is the room the player's in. If that guy does exit exist, input line, which is the direction they typed. If that's true, we'll print out try to exit to the blah blah. Else, system.err.println, there is no exit to the input line. Input line. All right, so now if they type in anything other than exit or look, we assume they're trying to leave the room. We'll say if the room the player is currently in, that's what that says right there. The room the player is currently in has an exit in the direction stored in input line, whatever the user typed that wasn't look or wasn't exit. And it's going to return for us a true or false. It's going to return true if there is an exit in that direction. It's going to give us false if there's not. But if it's true, we'll get inside this if statement. We'll print out, try to leave to the whatever they typed in, north, south, east, or west, where we know there's an exit. So add code here. We know there is an exit in this direction. Otherwise, we're going to yell at them and say, you gotta, there's whatever you type doesn't work. Okay. Go and run that. So we see obvious exit to the north. I'll go ahead and type in woot. It's going to say there is no exit to the woot. I'm going to type in north. It's going to say try to leave to the north. It found an exit to the north. If I type in south, it's going to say there is no exit to the south. So it's only finding an exit to the north. Make sense? So your homework is to make your guy be able to traverse the entire map. He should be able to leave the current room and go into the appropriate room based on the direction he entered. Make sense? I'll give you this code as the starting point. I'll put it up on Canvas or blah, blah, and then, yeah. So I would say this should take between 12 and 30 hours or so. Some of you will struggle with this. Some of you will find it not overly difficult, but it's part of putting the reps in. Questions, comments, concerns, bribes? Nope. What do you want to see?
Very bottom there, where it's like does exit,
This guy.
yeah. You put it all statement at the end.
And I'm going to have a link out. In fact, I'll give you the link to the code inside of Slack right now.
You did it. No, because I take notes like in my code.
Yeah, that's fine. I'll leave it up too. But let me just get it into our Slack channel. I'm lost. What happened to my Slack channel? Oh, well, here, I'll just leave the code up so you can look at it. I'll get it in the Slack channel in a second.
I can't figure out how to convert a dictionary key set to an array.
Or a dictionary key set into array. Okay.
Or a key set or the.
What are you trying to do? Like, can I see the code?
Yeah. So I'm trying to basically just get a random room to. So I want to change a room. I'm going to get the room and then the direction because I have a map that has the direction in a string like north, south, west, and east. And
Was
the
it
room
just an
has-
array or you actually put it in a map?
It's in a map.
Okay. Why? Well, whatever. Just keep going.
Because well, I was using dictionary, but this thing keeps telling me to use map instead.
Okay.
So
Yeah. So, we'd have to look at the documentation. So this is Java map class we're using.
well, because I thought I'm using what it says online to do,
Yep.
which is entry set to array, and then the array, but it's giving me this error down here.
And where's entry set? Can you point to it? My eyes suck.
Entry set. right here.
Okay, room
Line
exits equal to
46.
start room dot, so exits dot entry set. So show me, so you have a function called entry set. Because exits is what kind of value is exits?
Exits is a map of.
Okay, so we want to look at entry set here. Okay, so here's a map. Maps take in two things. So the type of key maintained by this map and then the
This
map
is-
values.
This is exits.
Okay, so it's a string in a room. Okie dokie. And we look at what's called entry set, this guy right here.
Mhm.
So entry set returns a set view of the mappings contained in the map. So you're giving it a map that looks like that. It's going to return something called a set.
Okay.
So let's see what we get. So this guy is an interface that follows the rules of a map. So really it is returning well, we can just go look at entry. We can look at set anyways. It'll tell us what its capabilities are. And what do you want to get?
To array.
You want to get it to be an array right here, to array.
Mhm.
Yep, so we can do that. But it
So
gives you a generic object array.
Generic object.
What do you want
Oh,
it to be? So you
Is-
probably
is
have to
that
cast
the
it.
problem that I'm casting it as a room? Is that
Well,
the problem?
You're
I didn't
not,
put it as
you're
a
putting it
value.
in a room, so you need to cast it. Oh, but I'm actually surprised. What's the error message when you hover over? Oh, hold on. You're calling to array. To array doesn't take any parameters. You're passing it something.
Well, it says that I tried doing it without parameters and it
Well,
wouldn't
that's what
work.
it takes. It takes no parameters. Oh, here's the second one. Polymorphism. So this guy returns an array containing all the elements in this set. So you were passing it,
Yeah,
go ahead
'cause
and put
when
it back
I
in.
do no, it gives me that.
Yeah, but you were passing it, why are you passing it set dot, oh, wait, hold on, you're not passing it. What it expects you to okay, it expects you to pass it in an array of type T. So type T is going to be a room. So you're passing it.
So should I pass it? Should I make exit room separately and then pass it in?
Well, no, this is okay. So, but what you're passing it there is an empty array. So new room 0 is an empty array. This is, so this is an array capable of holding 4 things. So when you say to array, you're giving it return an array containing all the elements in this set. Return array containing all the elements in this set. The runtime type of the returned array is that of the specified array. Okay. Yeah. So what you need to do is you need to give it I think you just try just typing in room there. And if room doesn't work, just type in room, open, close, square brackets. Because what you're doing here is you're telling it the type of value you want it to return.
Also, when you're done with that, can I just see how it runs?
Yeah.
Just when you're done.
It gives me that. Do I need to put a number in there?
No number, because what you're doing is you're giving it a type. So take the brackets off first. Just try room. Hover over that. What does the error say? Room cannot be resolved to a variable.
Do I need to do like, what is it? Room.class or?
So this
Yeah, 'cause
T
I
thing
fallen
lets
for-
you work with generic types. So if we do set to array example with, let's do to array. So whenever you see T, it's like a generic type. It's called generics is what we're working with. So let's just see what this guy gives us. Ooh, we're gonna get some AI stuff. To array. Oh, I see what you're doing.
that's
Yeah.
what
So
it says.
go ahead and put in new room, open square brackets 0. Yeah, seems like you were doing the right thing. And then let's look at the error it gives you. You might just need to cast it to a room array. It's not actually giving you an error right now.
Yeah, it's not an error. The error is what happens down here, which I
Okay.
don't understand why that's happening.
Abstract collection to array. Okay, I think that's the problem, is you need to put open parenthesis, room, open square bracket, close square bracket room.
Is it because right now
right
it's
before
just a
this.
generic object?
Yeah,
Is that,
what it's returning is it's not returning a generic object, it's returning a generic array. So I think it wants you to cast it to a room array.
okay.
All right, you want to see just the code run?
It
Sure.
doesn't let me do that.
Alright.
Oh, wait.
Where am I at?
And if
So you
just
think,
type
you think
it-
that will work then, just casting it?
That's what I believe.
Okay.
Or whatever syntax Java requires for you to say, I want this to be a room array.
Yeah, it's this, I think. I need to look up how to cast it, but I think it's.
So this is it running right now?
Yes, and if you press R2, it's gonna give you that.
Well, R2 is not an option.
But it'll give you the specific error message we.
It's not an error message. It's just saying there's no exit to R2.
Yeah,
That's not one of my directions.
so you would consider that just a print error or a system doc or a system.
Well, I did it through system.err, but I mean, it
Like-
told me the obvious exits are only north.
Yeah,
We happen to know that to the north is R2. But the way to get there is by going to the north.
and we haven't done that.
Well, that's what your homework's gonna be, but you don't type in R2 anymore. You'll type in north.
Okay.
And you will just happen to end up in R2. That's where you expect to arrive, is in R2.
Getting the same error.
All right, come to my office real quick. We'll look at it. I'm sure we can fix it.